Welcome. The next topic that we're going to focus is balancing chemical equations. Now, there's two ways to approach this problem. The first one is where I give you an equation, it already contains formulas, and you just have to balance it. The second way to look at it is for me to give you names of compounds on either side of the equation, and your job is to actually come up with the formulas first and then balance the equation. And when I mentioned several times throughout my videos that chemistry is a lot of related concepts connected together, and I want to continue showing you that what you learned previously has some impact on what you're going to learn next. So with that in mind, let's get started. So I'm going to put these three equations on the screen. Now, as far as balancing a chemical equation, like especially when you're given a formula, it's more math than chemistry. Here's a tip I can give you. The element that you want to balance last is oxygen. Why? Because 98% of the time, by the time you balance and account for all other elements, usually it's like oxygen tallies out itself. If not, there are rare cases where you have to go back and change things significantly to make the equation balanced. But as a general rule, do not start with oxygen because it can lead to more confusion than actually helping the problem. So, you don't ever start anything with something very complicated. So I'm going to start with something very, very simple. With that in mind, okay, I'm going to start with nitrogen. Okay, on this side of the equation, let's think of this as left and right. Okay, on this side, we have two nitrogens to start, and we have two nitrogens to start. So there's really nothing we can do in this case to, do anything about the nitrogen because they seem to have the same count. However, we have 2 oxygen and we have 5 oxygen. Now, this is a special case, and the reason I chose that is whenever you have a single element, okay, like oxygen, okay, and when you have 2 and a 5, that's a ratio of even and odd. Basically, if you multiply this by 5 and this by 2, and how do we actually do that is, let me rewrite the equation. So N2 plus O2 going to N2O5, right? So I'll put a 5 here and I put a 2 here. Even though there's an N2 in the molecule, we're really worried about the oxygen, so put a 2 here. Now, what have I done here? Well, right now I have 10 oxygens, right? After this, I have 10 oxygens on either side, right? But what I've also done here is I have changed my nitrogen. On this side, I have 2. On this side, I have 4. Why? Because 2 times 2, right? 2 times 2. So my oxygen is 10, 2 times 5 is 10, 5 times 2 is 10, but my nitrogen quantity is now 4 on this side, 2 on this side. How do I make a 2 into a 4? Well, I just put a 2 here. Now I have got 4 nitrogens. Now, there is no set rule or method on how to actually go about doing balancing equations, which is why I gave you the one tip, which is leave oxygen for the end. As I said, this is a special case where you have a single element that's odd and even, but it's also easier in that sense. All you have to do is, if it is 2 and 5, multiply the 2 by 5, multiply the 5 by 2, so you get even number of oxygens on the side, and then in the process, we manipulate it. So what I really want you to take away from this is not so much the actual example, but the fact is, when you change the count of one element, you might inadvertently change the quantity of another element. So you always have to go back and check every element to make sure that this is a well-balanced equation. Now, as I said, there's more math here than chemistry, but as we go further into the topic and learn something called stoichiometry, if you don't have a balanced equation, the chances of you ever getting the answer right is basically none. There's no slim to none, it's basically none. So understand it, and if you have problems, ask me questions. All right, let's move to the second one. Now, as I said, leave hydrogen for the last. Now, when you have elements within a bracket and you got a subscript, that subscript can only be multiplied to what's within the bracket. The number in the front, like in this case, the 5, if the number is in the front, it's multiplied throughout, but the subscript only belongs to the elements within that bracket. So let's look at this problem. We have 1 aluminum and we have 2 aluminum, right? And we have to total it. So we have 1 carbon, and we have 3 times 1 is 3 carbons. And we have 3 hydrogens here, plus 2, that's 5 hydrogens total, right? 3 plus 2. And similarly, we have just 2 hydrogens on this side, okay? As I said, the moment you'd start taking care of the aluminum, things would automatically become different, and you will see it. And then we have 3 plus 3, 6 oxygens total on this side. And then on this side, we have 3 plus 3, which is 3 times 3 is 9, plus 1 is 10 oxygens, okay? Now, this is something that may be very alien for many of you, but trust me, this is very, very easy once you start doing a couple of problems. Now, I always prefer to start with my metal first, which is aluminum. On this side, I have 1. On this side, I have 2. So what do? I multiply this side by 2, which means I just put a 2 in front. Now, this is where I really want you to focus. Now, my aluminum quantity is 2. But what have I done to all other things? Well, this is 3 times oxygen times 2. So my total oxygen count now is 3, right? Times 2 is 6 plus 3. I've changed my thing to 9 oxygen, right? What have I done to my hydrogen? Is 3 times 2 is 6, and it's 8 hydrogens, right? And then I have not changed my carbon count. Now I have 2 hydrogens on this side, right? As I said, your carbon is 3 again, right? And then you have 1 carbon. So what if I put a 3? Multiply this by 3. Now I have 3 carbons. What have I done in the process? See, these are now same. But what have I done is I have basically changed my hydrogen and oxygen count. And, so 6 plus 6 is 12 hydrogens, right? And then I have changed 9 plus 3 times 2 is 6. So it's 9 plus 6 is 15 oxygen, right? As I said, don't panic. Just solve the hydrogen. Your oxygen would probably tally up. All right, so we now have 12 hydrogens. We have 2. So how can we make 2 into a 12? Multiply by 6. So I just put a 6 here. Now I have 12 hydrogens. So hydrogen count is the same. Now let's look and see if my theory about solving everything and then leave it the oxygen in the end, it tallies out. So we have 3 times 2, 6, right? Plus 9, 15 oxygen. And then we have 9 plus 6 is 15 oxygen. And there we go. This is a balanced equation. If there's no number in the end, just put a 1. There we go. It's not hard. Of course, I'm speaking from my perspective. I'm not speaking from your perspective when I say it's not hard. But again, it's not chemistry here, it's just math. How you proportion things is you have to think really hard about this. Let's practice one more before I wrap this video, and then I'll make another video from, like I said, the second vantage point. All right, as I said, we have 3 plus 2, 5 hydrogens total on this side. We have 1 phosphorus, and then 4 plus, this is 2, so 6 oxygens, and then 1 calcium, right? That's what we have on this side. On this side, we have 3 calcium, 2 phosphorus, right? And 2 hydrogens, and 6 plus 1, 7 oxygens. As I said, start with the metal, which is easy. So we have 1 calcium, we have 3. So if you get 3, you multiply by 3, so put a 3 here. So what have we done in the process? Well, we converted the calcium to 3, which works out. But what we also done is, this is 1 times 2 times 3. So now we have 6 plus 4, 10 oxygens, right? And then 2 times 3 is 6 plus 3, 9 hydrogens, right? As I said, simple thing. We got 1 phosphorus now, we got 2 phosphorus. So what can we do? We'll just multiply 1 times 2, which will make 2 phosphorus, right? So, but what have we done in the process? We have changed the hydrogen count. This is 6 plus 6, which is 12 hydrogens, right? And then we've also changed the oxygen count. It's 4 times 2 is 8, plus 6 is 14 oxygen, right? All right, now let's go to the hydrogen. We have 12 hydrogens, we have 2. We multiply the 2 by 6, we get 12 hydrogens. So I put a 6 here. So now my hydrogen is done. If you go back, my theory about oxygen tallying out would work. So we have 4 times 2 is 8, plus 6 is 14 oxygen, right? Now we have 8 plus 6 is 14 oxygen. And there you go, put a 1 in front. And that's not hard. Again, I highly recommend you first stay on the video, pay attention to what I've been saying. Just don't try to, store it all and then try to memorize. It's just not going to work, because you can literally solve this. There's no need to memorize anything, because each equation is different. So this is one way of doing things, which is probably easy for some of you, because there's no added difficulty of you coming up with the formula. So I'm going to stop the video here. This is how you balance a chemical equation given the formula. The second one is a little hard because you have to come up with the formula. But again, that's why I taught you how to create formulas in the previous videos. So stay tuned.